everybody. So in this video, I'll be discussing and making the topic of biostatistics, which is a very dry, boring topic into a slightly simplified version regarding all the important aspects which we as surgeons need to understand whenever we are dealing with either our thesis or a research article or any competitive exams. So to start off with, of any study, the most important portion is the sample size. So we calculate a sample size, we take the population where we are going to do the study, or we are going to apply the research question to, and then we study the results. To study the results, we first of all devise a hypothesis which is known as a null hypothesis, and we term it as whenever there is no difference between groups, we term it as a null hypothesis before we start the study. So we consider that whenever we are comparing two groups, there is no difference between them, and that is the null hypothesis. After the study has been done, we start off and we see the results. Now, if there is a difference in outcome in our study, even if there is no difference, so basically between the two groups there is actually no difference, but the results in our study show that there is a difference, then it is known as a type 1 or a alpha error. And if there is in our study, it results show that there is no difference in outcomes, whereas there is actually a difference between the two groups, then it is termed as type 2 errors or a beta error. Very simple to understand. So type 1 error is when there is no difference, but our study showed there is a difference. And type 2 error is that there is a difference, but our study shows that there is no difference. So this is a very simplified thing, very hot favorite for various competitive exams. Next, whenever we want to do a study, we frame a research question. So the PICUT framework is used to evaluate the research questions. So what do we see in this? So there are 5 variables. So we start off with the population of the problem, that is a sample size where we need to do the study. Then comes the what we are going to study, that is either a therapy, either a preventive measure or a diagnostic test, or various groups exposed to certain level of carcinogens, or the various effects of the physical health lifestyles, that is intervention. Then comes comparator, that is the other group or the control group where we are going to compare the research group to. Then we study the outcome, we do the results, and T stands for time frame, that is a time duration during which we are going to study and do the follow-up assessment. Now, whenever we do a study or we do a diagnostic test, we evaluate its sensitivity, its specificity, and its predictive value. Now, we divide the table of 2 by 2, whereas in this side or left side, there is the diagnostic test showing either positive or negative results, and the horizontal axis showing the true disease states, that is either they have actually, or the test should be positive, or actually the test should be negative. Now, if the true disease state shows that it is positive and the test also shows it's positive, then it is a true positive. If the test shows positive but there is actually no disease state, that is false positive. If there is positive disease state but the test shows negative, then it is false negative. And if actually the test and diagnosis are all negative, that is true negative. Now, how do we calculate this sensitivity? So sensitivity is to, out of all the cases, what is the percentage of the true positive, that is its sensitivity, and how much we are able to screen out, so that is true negative, that is shown by the specificity. So the sensitivity is given by true positive compared to all the cases. So the true positive is defined as we go like this and like this. So A, B, C, D. So true positives, that is A, divided by the all the number of cases wherein the disease is present. So that is A plus C. So that is sensitivity. Specificity is true negatives, that is D, and divided by the D divided by all the non-cases. Non-cases means there is no disease. So that is D divided by B plus D. So sensitivity is true positives out of the all cases in which it should be positive. So that is sensitivity, and specificity is true negative out of all the cases where the report should have been negative. So that is the specificity. Now coming to actually the predictive value. So basically that the number of patients who are tested, what is the probability of giving a positive test and a negative test. So the positive predictive value is defined by the cases identified, defined by the all positive tests, not the cases. And negative predictive value is all the non-cases or wherein the report is negative, where the disease was actually not there, divided by all the negative tests given by the report. So the positive predictive value is the probability that the subjects with a positive screening test actually have the disease, and the negative predictive value is that the patients who are given the negative report are actually not carrying the disease. So to see the formula, positive predictive value is true positive divided not by the cases but the number of positive results given by that particular report. So that is A divided by A plus B. What was the sensitivity? It was A divided by A plus C. That is a number of cases. Positive predictive value is the number of positive reports given by that particular test. Negative predictive value is the true negative, that is D given or divided by the number of total negative reports, that is C plus D. So I hope it is clear. Sensitivity, specificity, positive predictive value and the negative predictive value. Now, how do we define a sampling process? So basically we define the population where we are going to do the study. We develop a sampling frame, that this should be the demographics of the population. Then we determine the size according to the time duration and according to what results we are planning to explore. Then we specify the sampling method, and finally we come to selecting the sample. It is not just randomly we select a patients of 50. We do through the following process. Now we have seen about the test. Now we come to the types of study. To simplify it, it is divided into by this flow chart. That is, it can be experimental and observational. Experimental are divided into control and uncontrolled trials. Controlled trials are again subdivided into randomized and non-randomized. Observational are divided into cohort, case control, cross-sectional and a case report and series. Cohort study are again divided into prospective and retrospective. Now coming to what kind of studies are there. So observation is that basically we evaluate a treatment or a disease in a population. So we just see what is going on, we observe and we give the result. Retrospective is we analyze the past. Prospective is we study as the time goes. What is case control? So we compare a patient's group with a disease with a control, match control group. Cross-sectional is that we measure a particular hypothesis or the various parameters on a single occasion, and then we apply it over the whole population. So we select a group of people, we see the results, study, and then we generalize. So that is cross-sectional. What is longitudinal? So we take the measurement over a period of time in a population. So if cross-sectional, that means we take at a time. In longitudinal, we take over a period of time, but in both of them, we do it on a group of patients, then we expand the results. What is experimental? So either a surgery or a drug or a diagnostic test is studied, like between the two are compared. So we do a blind study wherein allocation depends either on the researcher or it is a totally blind study. Randomize is we randomly allocate two treatments and then we compare it. Randomized control is that we also have a control group. Randomized study is that we just give two treatments to a population and we study the results. Randomized control is we give the treatment and we compare it with a control group wherein they don't undergo any treatment or they undergo a treatment which is already approved. So To study randomized control trial, as I told, so we either do experimental group and a control group, and that is some majority of the time it is a blinded study. So we can establish the effect between what exposure we are studying and what is their outcome, and we can use it for more than one intervention. It is not necessary that we need to study only one intervention. We can use multiple intervention because it is a randomized study. Only issue is that it is expensive. It takes a long period. Very rarely occurring events we cannot do because it is randomized. So we don't know what is the probability that what we are planning to study will actually happen. And because we select a particular group of people, we cannot generalize the results. So it has a low generalizability. Coming to cohort study. So cohort of subjects is compared based on different exposures. So we study from what the exposure has been and what is the outcome. So that is how they are compared. So basically, because we are comparing exposure, we can generalize it, and rare exposures can be done because we study only that exposure or the group of people who have been exposed to that thing, and multiple outcomes can be studied. Now it has some potential because sometimes it can be used for rare exposure. It cannot be it does not have the potential to establish the causal effect that due to this exposure this disease has occurred. A patient having both smoking and also having a non-vegetarian diet, we cannot say that the esophageal cancer or the colonic cancer is linked to both smoking and non-vegetarian diet. Obviously it is linked to both, but because of this type of study, because of the exposure to outcome effect, we cannot establish a causal effect that this is X is happening due to the Y exposure. And again, it can take a longer time duration because we are studying from exposure to outcome. There can be selection bias because we are only taking a particular group of patients who are exposed to that. And again, it can be expensive. Case control. So cases are taken and control group is there, which does not have that disease or which does not have that effect. Now again, same, it can be used for rare outcome like cohort study. On the biggest advantage is it is inexpensive because you're already taking cases and control group, and we can generate a hypothesis that because this group of people have this exposure is linked to this disease because we are controlling with a control group. Now the disadvantages: selection bias. Because you're already taking cases, the recall bias is there. Cases means already the effect has happened, and it has a very limited potential because of the bias which is occurring, and it can study only one outcome because we are taking pinpointing to that outcome and then we are taking the cases. Cross sectional, as I told, take a group, study effect at a one particular time, and then you generalize it. Now disease prevalence can be studied by cross sectional study. Again, inexpensive, fast, and we can generate a hypothesis. But again, as we are taking only a particular group of people, sample bias, survival bias, because we are studying at a point in time, and very limited potential. It cannot be used for causal effect because we are taking group of people and we are generalizing it. So we cannot say that there is a causal effect due to a particular exposure or a treatment or a diagnostic test. Case series and report. What we generally do, we do a case, we report it. So it is either one or more of patients. We are studying a treatment, a diagnostic test, a disease. So it is detailed, inexpensive, hypothesis can be generated, but we are taking a particular group. So it is a selection bias is there. We cannot generalize it and we cannot establish causal effect. Now coming to whenever we are doing a study, we take the central tendency of the statistical data. So most commonly used measures are mean, median, and mode. What is the mean? So it is the average. So that is, take all of the values in the population of the sample and you divide by the number of values. So if there are 10 patients, you take the age of all 10 divided by 10. So that gives you the mean age group. Median is the middle value of the data set. So when you arrange it from lowest to highest, so what is the middle value? That is the median, or by formula it is n plus 1 divided by the 2 that value is given as the median, that is a middle value. What is mode? So it is the most frequently occurring value in the set of data. So there can be more than one mode. So if the age group like 10 patients are there, three group of patients have age group of 54, 55. So both can be the mode. So there can be multiple modes can be there. So that is mean, median and mode. Now range we all know, the lowest and the highest. Standard deviation is so how much the data differs from the mean. So if the lowest, if the mean is 50 and the highest is 60, lowest is 40. So the standard deviation can be said of 10 plus minus 10. Now after we do the statistical analysis, we generate the results. So we make certain diagrams. So pie chart, it is best for a multiple segments. Like for example, out of all the patients, this one are suffering from hypertension, diabetes. So if 10 patients are there, 3 patients suffer from X, Y patient, 7 patients suffer from Y. So that can be arranged in form of a pie chart. So 360 degrees are divided according to the data. So histogram, it is used for a frequency. So for example, the patients are suffering or their age group is divided into 10 to 20, 20 to 30, 30 to 40. So how many patients are there in each of them? That can be represented in form of histogram. So this is how a histogram looks. Frequency polygram, again, what you divide into the bar histogram, you can also represent in terms of a frequency polygram, where you just mark the data set and then you connect it. So this will give you a frequency polygram or the frequency of that particular data set, and you arrange in form of a polygon. Line diagram is used whenever we want to chart the difference or the changes in the value over passage of time. So that is when the line diagram can be used. If you're doing for a data set, it is frequency polygon or a bar histogram. But if a particular data set you want to study over a passage of time, then it is a line diagram. Then what is stem and leaf plot? So it almost similar to histogram. So it is either like you arrange from lowest to highest with the highest concentration and the lowest concentration of the various data set frequency or the concentration of measurement. This is how a stem and a leaf plot appears. So if you say the data set of age group saying 3 years, so you arrange it that this many patients are there in that age group. Now this is an example of a box and whisker plot. No need to go into detail. Now this is how it appears, the box. So this is the box and this are termed as whiskers. So this is also known as a box and a whisker plot. Now coming to the recommendation. So recommendation and the quality of evidence. So what is high quality of evidence? So that means that what they are saying, for example, a group of people sit together and they decide that if a patient undergoes this diagnostic test and this is the result, and we are confident that if we term it as a particular diagnosis, then it will be close to the actual diagnosis, then it means that that test has a very high quality of evidence and the strength of recommendation according to that test is strong. For this high quality of evidence, what you need to give? So many high quality trials need to confirm it. Then only we can say that this particular test, treatment, drug has a high quality of evidence to be used in a particular group of patients. Moderate. So there is a certain desirable and undesirable test, and the effect estimate we are moderately confident. So that is a moderate quality of evidence, and recommendation can be conditional. Low and very low. So basically confidence in the estimate is limited or very little confidence is there, and very conditional strength of recommendation. So that is when you do give it as low and very low strength of evidence. So this is all about what all things we need to know whenever as a surgeon we need to study biostatistics. So regarding the various results, how do you display it, the quality of evidence, the standard deviation, mean, median, mode, the various types of studies, and the sampling process, the sensitivity, specificity, and the positive negative predictive value of a test, and the type 1 type 2 error and the hypothesis testing. I hope I am clear and this is simplified for you to understand. Please go through the video again if you're not clear, because it is slightly dry and slightly confusing, but if you just understand the basic, it will be very clear for you. Thank you so much for watching.